Now that we know what the mole is and we know what Avogadro's number is, we're going to be able to go not only from moles of one thing to atoms or particles of something else, we can also go from moles to the mass of an object. So if you look at your periodic table, you see all these little numbers here down at the bottom. And these, depending on what periodic table you look at, there can be more or less decimals. We're only going to use the first two decimals. So if you look at hydrogen here, you have 1.00794. We're only going to use the first two decimals, so that's going to use our rounding rules. So if you underline this guy and look to the right, we're only going to use for hydrogen, instead of this big number, we would only use 1.01. But the reason that I want to draw your attention to that is those numbers at the bottom are also the mass of every element in grams for our next type of conversion. So the atomic mass of that element can be expressed in grams as a measure of how many moles. So, for example, the molar mass is what we typically call that little teeny tiny number at the bottom of our periodic table. For carbon, for example, it is 12. So if you go back to our periodic table, you can see, there it is right here, this one says 12.01, so they only used 2 decimal points. But for this class, they only use 1 decimal point, where we are going to use 2. So for example, if we were to look at carbon, its mass number on our periodic table is a lot longer. We only want to use those first 2 decimals. If you were to look again at hydrogen, they only used 1 decimal instead of our 2, but it says the same thing. The molar mass of that element tells you how many grams are in 1 mole of that element. So it's often expressed in grams of that element per, or divided by, 1 mole of that same element. So you can see a couple different types of substances here. You have carbon on the left, sulfur in the center, and you have iron on the right. There are different amounts you can see in each one, but in each one there's always 1 mole of each one. So you can see how molar mass is going to be measuring out different amounts of that same type of unit. So 1 mole is equal to 12 grams of carbon, whereas it's going to be 32 grams of that sulfur. And this isn't actually the correct number. This is a typo. Instead, it should be around 55 grams in that beaker right there. So you have lots and lots of different and varying amounts that make up 1 mole of an element. So whenever you are looking at how many atoms you have, you can relate our number of particle units to the molar mass by going through the mole. The mole is what you have to get through every single time in order to go from one way of counting to another. It is that linking factor. And this is a brief history on how we can further define that mole. I'm not concerned that you know this portion, but it is kind of interesting to know that it is the number of representative particles in that of carbon. So that's just some history. This isn't a big idea that you need to know, really. But to find the mass of a mole of a compound, you have to know the formula, because you need to know how much or how many grams of each type of atom are in our example or in our compound. So for example, we have SO3 right here, which has 1 sulfur atom because it has a subscript of 1, and 3 oxygen atoms, which has that subscript of 3. And because of this, we can now determine its molar mass, or how many grams would be in 1 mole of this compound. And to do so, you would need your periodic table, so make sure that's out. So once you have your periodic table, we can now determine how much of each we have. So what I like to do is I like to write out a little chart of each of the compounds that we have. The next thing I like to do is write the number of atoms in the next column, and then their molar mass, or M from your periodic table. Then we write out your total for each one. And at the bottom, I write the sum. All right, so for the sulfur, we have 1 sulfur atom and 3 oxygen atoms. If you were to look back at your periodic table at sulfur, oh, there he is. Sulfur has a molar mass of 32.07, it looks like there. So I'm going to put down 32.07 in our molar mass. And now let's go back to oxygen. If you circle oxygen right there, sorry, I kind of put that in the way, I'll try again. So oxygen right there, it has, I'm going to make that 16. So it has a molar mass of 16. So now what I want you to do is multiply straight across. So 1 times 32.07 is 32.07. Then 3 times 36, that should be 48.00. Now you're going to add up the total column. So you would go straight down, just like normal math, and you would get a total of 80.07. That is going to be your molar mass for that of sulfur. So if you were to write it up here one more time, its units would be grams per 1 mole. That's your molar mass. So anytime you are trying to determine this portion, you want to make sure you make a chart just like this one to make sure that you are counting all of your elements, you are multiplying the correct number by its molar mass, and totaling up everything together. When you're calculating the molar mass of a compound, you want to make sure that you're going to be finding the number of grams of each element in 1 mole. So the unit of your molar mass is going to be grams per mole every single time, but the quantity that you're going to be finding is going to be different for each compound. So it is very important as we carry on to be able to do this. So that chart that we made on the last slide is important. Make sure you know how to set that guy up. All right, let's see if we can give this one a shot. So we're looking at the decomposition, which we know is the breakdown of hydrogen peroxide, which looks like this, to provide sufficient energy to launch a rocket. So we're trying to find the molar mass of hydrogen peroxide. So if I were to write out our chemical formula, H2O2, I would start by making our chart where we have H and O in their own column. We have the number of atoms, the molar mass, and that's going to come from your periodic table. Of course, this is my favorite part. It makes me think of M&Ms. And then we will have our totals here on the far left and the sum at the bottom. So if you were to look at your subscript, for hydrogen you have 2 atoms. For oxygen you also have 2 atoms. Now let's take a look back at your periodic table. For hydrogen, remember we already did this one, it's going to be 1.01. So I'm going to write that guy right in our molar mass spot. And then oxygen, if you remember from last time, is right here, number 8, and we're going to round that to 17 or 16. All right, we're going to multiply straight across, and we will get 2.02 for hydrogen and 32 for our oxygen. Adding up this total column, we would get 34.02 grams per mole of hydrogen peroxide. Guys, that does it for me. I'll see you next time.